Okay, everybody. Now, we've got the scatter plot together, which means we can see the interplay of the speed variable and the perception distance variable. And you might have noticed something when you look at them. You might have noticed that it looks like they're kind of progressing in a straight line. What I'd like you to do is, I'd like you to go back to the original text from the Oregon Driver's Manual, and I'd like you to look down at these footnotes down here. Hit pause, read those footnotes right there, and see if you can figure out why this straight line is here based on those footnotes. Go ahead and hit pause and think about it. Driver reaction distance is based on a perception reaction time of 1.5 seconds. This is an 85th percentile range value that has been accepted as an industry standard. Okay, so don't get too hung up on that second sentence because it's just a Math 243 kind of a stat point. It's the first sentence I want you to think about, and I want you to break it down like this. Don't even worry about this percentile range. When they say driver reaction distance is based on a reaction time of 1.5 seconds, that means on average, it takes drivers 1.5 seconds to realize they have to stop. Now you can see that the faster you're going, the more distance you're going to go in 1.5 seconds. For example, if you're going 20 miles an hour, that means you're going 29 feet every second. If you take 1.5 seconds to realize you need to stop, you've got to take 29 plus half of 29, which is where they get 44. If you're going 30 miles an hour, that means you're going 44 feet per second. 1.5 times 44 equals 66. So that's where those are coming from. So that should also explain, hopefully, why this appears to be a straight line. Because it is a straight line. In case you don't believe it's very close to a straight line, you can add what's called a trend line to it. And that's the point of this video right now, is we're going to show you how to add a very special feature called a trend line. So we're going to go back up to the dispensary cross, and we're going to add what's called a trend line. And you see that right there? That trend line right there shows the behavior of the points from 20 to 30 to 40 to 50 to so forth and so on, lies along a very, very convenient trend that is linear, which means that the data points are trending upward consistently. So if you increase by 10 miles an hour here, and you're increasing by 22 feet here, for every additional 10, you're going to increase by 22. For every additional 10, you're going to increase by 22. It also cuts it half. For every additional 5, you're going to increase by 11. 5, 11, 5, 11, 5, 11, and 10, and 22. And that is what a linear trend line looks like. Okay, in the next video, we're going to look at some other kinds of quote-unquote trend lines and how they behave.